Okay, so what we went over last time is this fact that there's this task. So I want to go over the control flow one more time here because it looks a little bit confusing. So we're going to start, well, there's just a class definition. So this just goes, boop, goes right over it, defines a class. We're going to make a fetcher. So remember that a fetcher is up here, right? We're just going to make a fetcher. Oops, sorry. A fetcher is just, well, there's no, the constructor isn't set yet. Sorry, we're going to make a fetcher, and we're going to do fetcher.fetch. And in our new form, this is a generator. So this just creates a generator object that will run this whenever we send something to it, right? Because it's yield. So when we're going to create tasks, so where does the control flow go? So we're going to do here, and then coro is the generator, right? This thing is the generator, goes into coroutine. We're going to create a new future object. We're going to set result. We're going to do step, and we're just going to call into here. Okay, so then what happens? We're going to, this is the fetch, the function that corresponds to the fetch generator. We're going to call .send on it, which, recall what send does is that it will pass control into the generator. So where are we going to send in? We're going to send in future.result. Right now, future.result is none. I don't know if did they have future somewhere? Yeah, maybe there might have been a typo here because I'm confused where this feature. Oh, sorry. I am confused. This feature is this feature right here. So, which is F, right? Yeah. Okay. That makes sense. So we're going to call step with F. F, it's the feature I made in my constructor. So I only have one feature in this task object. This is none right here, right? Because I don't send anything in. That's why we want to set result to none, because the first time you call a generator should be none, or else something breaks. So what do? We're going to call send. What is coro? It's fetcher.fetch, which is here. So we're going to run. We're going to initialize the socket. We're going to connect. We're going to create our own future, if you notice. So this is a separate future than the future down here, right? We're going to just create our own future as a local variable. We're going to do this socket register thing. Now we're going to yield F. So what does this do? This will now stop this function or pause this function and yield F, which is the future we created in here, to its caller, which is here, right? So we're going to yield F, which is the future we created inside of fetch. And this is going to be called next future now. It's a local variable next future. So what does that do? This now goes to next future. We don't have stop iteration, so we skip this. It adds the callback of self.step. So whoa, what just happened? This future or next future is this future here. And we're going to add a callback to this thing right here, right? We're going to add a callback, and the callback is the step function of this task. So basically, when you're all done, we're going to run this function again. Okay, so when does this callback run? This callback runs when this is the future, right, that we just added a callback to. So recall that the callback we added in this future was to this method out here, which has nothing to do with the fetcher object, right? So when does this callback run? It actually runs when the socket is ready to be connected to do stuff with, and on connected runs, which runs f.setResult, and recall that set result up above will set the result of the future and also call all the callbacks, right? And in this case, we have one callback. So what this does is that when it's connected, as soon as the socket is ready, maybe it's a second later, 5 seconds later, however slow your internet is, it will call this on connected, which will call set result, which will, lo and behold, call the callback. So where is the callback? Callback is down here, right? Because the callback is self.step. And then we're going to do, we're going to keep going. So what happens is we call the callback, we keep going. What do we do here? We're going to do .send again. The result is still none because we don't care about this. So what happens here? We're going to go .send, and we will now go back to this generator. Do we start from the beginning? No, we don't start from the beginning. We start from here, right? We start from after the yield because the second send will start, the generator remembers it was here. So what do? We unregister, we say we've connected, we unregister and we say we've connected to kind of clean up. So recall that the control flow is kind of bouncy, right? We start in task, we go here, we do all our good stuff, we register, then we yield back to task here, and then we add it to the callback. We add this step function to the callback. Now we wait for a second, 5 seconds, however long. When the socket is ready, we're going to call back here, which calls set result, which implicitly runs all the callbacks. And the only callback here is the step, which means we're going to go back again. And then we're going to call send again, which starts from here, and we're going to go down. So this is a really weird and convoluted way of just writing kind of control flow between the two. Okay, so this code example continues a little bit more with what happens after you're connected, right? So we finally connected, we are ready to go. So they extend this fetch example down here in this section. So this is same connection logic from above. So imagine this fetch is a continuation of this, and we're just going to keep on going down here. So what happens after we connect is we're going to send some the request. We're going to send the request. So this kicks it off. It's non-blocking, right? So now what do? We're going to have a while true loop. We're going to create another future of our own. So this is a second future here. So notice how the fetch, it's broken into two parts. The fetch has the first future, which is all done. It's yielded. It's done. We don't care about it anymore. So now what we do is we have a second future, well, a bunch of futures. So we're going to define an onReadable callback function, and this will set the result to socket receive. This will just say, when we're ready to receive some data, we're going to call socket receive and stuff the data into F, and then call all the callbacks that are waiting on me. So we're going to return. We're going to we're going to register this callback handler to the event when the file is ready to be read, when the socket is ready to be read. Now we're going to do another yield. So we're going to say, let's yield, and then we're going to have this chunk thing again. So where does this yield to? We're going to go back to our friend, the task queue. So we're going to yield back to here, and then the next future, it does the same job as above. Then the next future is this F now, right? This next future is this F inside of this while loop. Next future will add the callback. The callback is just step again, just give me another step. And then that means that when we are ready, we will run this onReadable, which will read a bunch of data, call the callback. So we'll read a bunch of data, call the callback, which is up here. And then we're going to keep going to here. So now this is another kind of trick, and then we're going to unregister the file, the socket ID. Okay, so now we have this chunk equals yield F. So now not only are we returning stuff from the generator out to the quote unquote caller, we're actually passing stuff in. So what are we passing in? We're passing in future.result. So this actually is not none anymore. This actually has some significance. So this is actually the result of the future, right? So this future is here. The result of the future when I first received is a chunk of 4 kilobytes of data. So when I actually send it in again, when I send in the future result again, this will get assigned to chunk. So chunk is actually this thing that's being bounced back and forth in the future. And then what I do is if there is a chunk, I'm going to append it to the response. If there's no chunk left, I'm going to break out of the while loop and I'm totally done reading. So this is the kind of convoluted way of explaining how something can read 4K at a time and yield control back to this task queue, and then bring the chunk back and then append it to the response, and keep doing this and keep making new futures. If you notice, we keep on making a new future every time through the loop, bringing the control back here, and then back until we're done.